this. Did you watch the video that I posted last week on explaining the exam? All right, so you watched it. Do we know where we messed up? Do we know where you messed up? Where was it? Share with me. What were you confused about? Share, and just give me one or two things that you were confused about. So you got confused on which one was a variable and where was the hypothesis. Kind of very important concepts. Okay, so is that where everybody was pretty much confused about? After watching the video, did you feel more confident as to what the variables were and what they weren't? How about you guys? Specifically, what did you what were you confused about?
The main thing I was confused about was trying to figure out kind of just which one was the independent, which one was the dependent.
Okay, so that's a good, that we can discuss that right now and try to clarify that. And what other issue was there with the variables? Was that the main issue, independent versus dependent? So it's the one, so independent has some qualities they should always keep in mind. The independent variable, as I discussed in the video, but an independent variable has to be is the one the scientist controls. The scientist changes. So the one that the scientist is changing or is planning to change, that's the one that's going to be the independent variable. The independent variable does not, silence, does not change because of a different variable. So if it changes because the scientists changed it, because you changed it. You're going to change how much light you're giving the plant. You're going to change how much water. And a thing that changes because you changed that, right? That's called what? The dependent. That's the main idea. There it is. No matter what the situation is, guys, whether we're talking about studying Arctic ice, or we're talking about plants growing, or we're talking about anything, if a scientist changes the variable and they want to see how does something else change, what happens if that changes, how does that change if I change this? Then the thing I'm changing in that sentence, whatever that is, that's the independent variable. The one that changes because of that, that's the dependent variable. Was that your understanding after the video? Okay. Now, what's the other thing we talked about just a minute ago that people were confused about? I forgot already. Hypothesis. That's right. So when we look at a hypothesis, when you're trying to find a hypothesis, when someone's talking or you're reading an article and trying to figure what was their hypothesis, you want to know what the hypothesis is. What do they think the relationship is? between the variables. So when they say, we think this is going to happen, if that happens, then we call that the hypothesis. So what do they think is going to happen? If they anywhere they state in the paragraph or in the experiment, we think this is going to happen if that happens, or man, we wonder if this is going to happen if that happens. Now they're talking about the relationship between two variables. That's your hypothesis. Another word that is often used when you're talking about a hypothesis is prediction. The scientist predicts that if they increase the temperature, this will increase. If they increase the light, that will decrease. Whatever it is. Then that is also another indication that you're talking about the hypothesis. Is that clear? With independent and dependent variable, always remember the independent goes here and the dependent goes on the y. Okay? Don't forget that, because that will be on the next quiz, on tomorrow's exam as well. Anything else? There were 6 questions. You got all the rest of it right? You just got these 3 wrong? Is that right? Oh, I missed 2. So you guys understood all the rest of that stuff? You're okay. You can... Should we go over what the 6 questions were?
Yeah, because I didn't take it.
Oh, you haven't taken it. So let me pull it up. Now, even though I'm telling you what was on the quiz, it's going to be a different quiz tomorrow. It's just going to ask you the same 6 questions, but it'll be about a different set of content, completely different experiment. Okay? Just so you know what to expect. There are going to be 6 questions. You're gonna look at the experiment and you're gonna read it, and it's gonna have tables and graphs. Okay? So you should pay attention, because they'll do this on the OST as well. Tables and graphs. And I'll say, what is the best question, scientists? You have to figure out how to ask a question. Do you know how to ask a question? If you're getting a certain that's testable, what's a good question? What isn't, right? Something that has to do with the content. You don't want to pick a question that has nothing to do with what you're reading about. Okay. The next is, what is the best hypothesis from those that were listed? We talked about that. You're looking for a hypothesis that has to do with the question. There could be a good hypothesis, it just might not be having to do anything with your question. Then that's no-go, right? So pick a hypothesis that matches your question. What is the independent variable? We just talked about. What is the dependent variable? What was the control group? Make sure that you look at the tables and graphs and find the groups. So what is a control group? Can you identify a control group?
That's like the thing that you compare, right?
The one that you're using to compare. In the experiment, it was kind of crazy, right? They had all kinds of graphs and everything. The control group was the ocean water. You remember that? Ocean temperature was the control group. Because it was all about, they were comparing all these different regions. Was it ocean salinity, wasn't it? How salty the water was? Wasn't that it? I can't remember. Let me look at the question. Yeah, the marine heat wave, so it was temperature. Ocean temperatures. The ocean temperature was the standard, and they compared the ocean temperature values to all the rest. They grew the normal ocean temperature versus the marine heat wave temperature versus the extreme heat wave temperature. They had a chart with 3 columns, right? And they tested 20 sea urchins. They said one of them didn't work out for whatever reason. They grew half of them. Turned out to be a little less than half because one wasn't present. So 9 sea urchins in normal ocean temperatures of 15 degrees, and they grew half of them in 18 degrees, a little warmer, the marine heat wave temperatures. And then they tested them by putting them into different experimental groups. One, they put the normal ocean, the one in normal. Let me draw it out. Wait, do you want me to do this? Is this helpful or not? So you had to read, and you have to ask yourself when you're looking at a table, what's happening? You have to ask yourself, what's happening with these in this experiment that they got this data? They took 2 groups. They grew a bunch of sea urchins in one group, 10 of them. Then 9, no, not 9, it was number 4, something happened to it. Doesn't matter, it's out. Then they took the rest and put them in another group. So 9 and 10 groups, they grew these in normal ocean temperature, and they grew this in warm. These were raised in warm water, or kept in warm water, and those were kept in normal temperatures. How do I know that? Well, 1, they explained it, but 2, it's in the chart. You see it? They explained it, and it's in the chart. You haven't seen it, so there you go. So their big idea was this idea of being acclimatized. Acclimate. Would they acclimate or not? If they were used to the warm temperatures, then they shouldn't slow down, or at least not slow down as much if they weren't used to it. That was part of their question, part of their hypothesis. And their big question was, does the warmer temperature slow them down? Does it put them into shock, which requires them not to be able to react the way they normally would? You've seen people in shock in movies, right? They're like so is that what's happening to the sea urchins? So then they took those 10 and those 9, and they put them in three different conditions. They repeated this experiment obviously 3 times. 1, they put them in a normal tank and timed they put the normal ones in normal water, and they put the warm ones in normal water temperature. And they measured the time that they fell. Tick, 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 tick. If the change in temperature was a thing, would you expect that cooling would bring it down or up? Like, what would they were predicting that you would expect that if shock was a problem, if change in temperature was a problem, then you'd expect that the warm water, ones that are raised in warm water, now in colder water, they would be in shock and they would move slower, right? If it's the heat that's bothering them, then they would move at the same rate. Slower or the same rate as what? The normal, right? So the normal is the one we're comparing it to. We're comparing everything to what the normal ocean temperatures. Normal ocean temperatures. Then they took it and they did it again, the experiment again. This time, this was normal. Then they took it and did it in warmer ocean, not the hottest, but warmer heat wave temperatures. Obviously, they kept everything else the same. The salt level, the nutrient level, the light, everything else was the same. The only thing they changed was the temperature. So they put this normal in warmer water, and they put the ones that were spent time in warm water in warmer water, the same temperature. So these two are now the same. If they're right, then you would expect that these guys that were the ocean temperature would slow down because it's warmer water. And these would then, if they do acclimate, if they do get used to their warm water, then they should keep the same reaction rate. They shouldn't slow down. So again, you're comparing these to what? The normal again. So still your comparison group. And finally, you take and put in the hottest water. And you try to see what happens here. Again, ocean temperature, sea urchin, and you put those same ones after they spent their time get acclimatized to the warmer water into even warmer temperature. And you'd expect, again, if their hypothesis is correct, that these would move slower. Maybe these would move slower than these because the normal ocean ones have the bigger shock, right? Because they have a larger degree difference between normal and warmest. But what's key is you're using the normal ocean temperatures, the normal ocean temperature values to compare everything to. So that's how we know that's the control group. All the rest every other component here is an experimental group. And when you write a table, the table comes out pretty straightforward. The sea urchin, right? 1 through 20. And then you had the time for those that were acclimatized to regular normal ocean. The tanks, so this is normal ocean tank. And then you have the warm ocean tank. And then you have the hot ocean tank. So these three conditions, these three experimental groups, let me use a different color. 1, 2, and 3 are from 1, 2, and 3. The three tanks you put them in. Then if you look at how they divided it, the chart up, they added a second layer. They divided the chart into two halves, 1 through 10. We're here at this temperature, which was again normal ocean temperature, and then 11 through 20. 11 through 20 and 11 through 20 wasn't normal. They were raised in the warm temperature. And then you had a bunch of time, right? Bunch of numbers listed here. Correct? And there was a lot of variation, right? There's a lot of variation in this. You had a couple extra credit. I have them here. I still haven't graded them. I apologize for that. But when we look at the extra credit questions, you look at these data. You had a bunch of different data. And there's a lot of variation in the data. So the way, I'm just giving you the extra credit answer now, right? The way we make sure we standardize for that data, an easy way to standardize the data is just simply take averages. And you can take the average in ocean, warm and hot for each of these, right? Average temperature for the ones raised in warm and ones raised in normal. See how they react, and then you can analyze and rationalize and come up with an answer to your hypothesis. But really, this wasn't about all that. This was just questioning, do you understand that you're using the normal to compare all your experimental results to? Are we good? I think that's every question. So if we understand, I'm seeing nods from everyone present. I expect to see 6 people here tomorrow if you want to retake this test. There'll be the same 6 questions that we just went over. The ones that you have, if you want your extra credit packet back, you can have it. Huh?
I
You have
do
to
mine during
find,
my study hall.
huh?
I do mine during my study hall. Because I got team meal after school.
You have to do what?
I got team meal after school. Can't be making-
Team meal?
Yeah, I gotta be there. I swear I'll be in trouble about this.
I'll talk to Coach Dissipator and ask him if he can skip it. You're not gonna be able to eat some ribs or spaghetti. Maybe he'll save it, keep it. What's the meal?
I don't know.
He usually brings ribs or has a barbecue, lasagna. He loves to make lasagna. I just see the spaghetti sauce. That's all I ever see. What's this one?
Can I also do their study hall, cause I have to do, weight tomorrow.
Ah, you guys are killing me. All right, when's whose study hall?
Mine's the period 4.
Yours is 4. And what about yours?
Mine is 9.
And yours is 7. 3 different study halls. And what teacher?
Mine is trouble.
I got a curriculum.
Before your study halls, well, if I'm doing it for you 3, I'm doing it for everyone, all 6 of you.
Okay.
So before your study halls, come here. Everybody here has a study hall, correct? No, you know what? Give, next to your name, put down the name of your study hall teacher.
Put my pencil back. Can I use that?
And I will take your test, the packet with your test, to them, okay? And ask them not to let you use your computer, but not anything else, okay? I'm trusting you. I'm trying to make your lives easier so you don't have to stay after school. Is that clear? But that also means if you cheat or anybody catches you doing anything scoundrelly, it'll be the last time you get to do it during school day and I can't watch you, okay? So don't ruin a good thing. Don't cheat. Are we all good? No more questions, no concerns. Excellent. Have a good one.